In this screencast, we will talk about literal equations. We'll talk about what they are, how they're useful, and how we can manipulate them in different ways. Literal equations are simply equations with multiple variables in them. And many equations with multiple variables in them are formulas. So we are going to be looking at a lot of different formulas in this section. Formulas are relationships between variable quantities that hold true under certain circumstances. Let's take a look at an example. Properties in cities across the country are often subdivided into rectangular plots. If a city has incomplete records, particularly missing widths of properties, but they do have the perimeter and the depths or the lengths of the properties, do they need to send someone out to measure the widths of the properties? So the information that they do have are the lengths of the properties, and they also have the entire perimeter, which is the distance around the outside. However, they don't know what the width is. But if they have the perimeter and they have the length, is it possible to find the width? Well, first let's recall what is the relationship between the length, the width, and the perimeter of a rectangle. You may recall that from the past. The perimeter is equal to 2 times the length plus 2 times the width. Right? If you had this is the length L plus W plus L plus W, that would give you the perimeter. And that's simplified as 2L plus 2W. These things are known. We know the perimeter and the length of each property. It's the width that we're not sure of what that is. Can we find it without having to send somebody out to actually measure the width of the property? Let's take an example. Suppose the perimeter of a property is 100 feet and the length of that property is 30 feet. Is it possible then to figure out what the width is without having to measure it? Well, we have the general relationship between the perimeter, the length, and the width for a rectangular plot. Let's plug the known numbers in to see if we can find the unknown number. So in place of P, I've got 100 equals 2 times in place of L, I've got 30 plus 2 times W. And if you look at this equation, it's a one variable equation. You absolutely can solve this equation for W. So let's do that. We've got 100 equals the 2 times 30 is 60 plus 2W. Then if you subtract 60 from both sides, that would give you 40 equals 2W. And then if you divide both sides by 2, you get 20 equals W. So we were able to determine the missing width. It was 20 feet. And this would be true in general. As long as you have two values of the three variables, you can always determine the third. And that's true if you had 20 variables. If there were 20 variables, as long as you know 19 of the values, all but one of them, you can determine the last value by plugging in the known values and solving for the unknown value. So here is a portion of the incomplete records. We got to find the missing widths. So we've got 4 addresses. These are their perimeters and their corresponding lengths. We need to find their widths. So let's go through each of these. Again, perimeter is 2 times the length plus 2 times the width. So here we've got perimeter of 180 for 1 Gauss Boulevard. So we've got 180 equals, in place of L, we're going to put the length of 50 plus the 2W. And we're going to solve that. And maybe we'll set up all 4 of the equations first, and then we'll solve them. 3 Gauss Boulevard has a perimeter of 170 equals 2 times its length of the property is 50 plus 2W. And ultimately, we're going to have 4 equations to solve here. We've got a perimeter of 176 for 5 Gauss Boulevard equals 2 times the length is 48 plus 2 times the width, which we need to find. And for 7 Gauss Boulevard, we've got a perimeter of 162 equals 2 times the width is, or the length, I'm sorry, is 48 plus 2 times the width. And we can solve all 4 of these to fill out the widths for each of these properties. So let's start with this one. You've got 180 equals the 2 times the 50 is 100 plus 2W. Subtract 100 from both sides, that would give you 80 equals 2W. And then divide both sides by 2, and we get 40 equals W. So the width of 1 Gauss Boulevard is 40 feet. Let's try the next one. we've got 170 equals 2 times 50 is 100 plus 2w. If you subtract 100 from each side, you've got 70 equals 2w, and then divide both sides by 2, and you get 35 equals w. So the width of 3 Gauss Boulevard was 35 feet. With the next one, we've got 176 equals 2 times 48 is 96, plus 2w. Subtract 96 from both sides, and we get 80 equals 2w. If you divide both sides by 2, we get 40 equals w. So the width of the property at 5 Gauss Boulevard is 40 feet. And then finally, this last one, we've got 162 equals 2 times 48 is 96 plus 2w. If you subtract 96 from both sides, you get 66 equals 2w. And if you divide both sides by 2, we get 33 equals w. So the width of the property at 7 Gauss Boulevard is 33 feet. To summarize what we just did, we had the impartial records for 4 addresses. We knew their perimeters and lengths, and then we set up 4 different equations and solved each of those 4 equations to get the corresponding widths. Hopefully you can see the power of the mathematics here, because if they didn't know they could do some basic algebra to be able to get the widths of the property, they would have had to have sent somebody out, maybe even 2 people, to measure the widths of all the properties, and they would have to pay those people for doing that work. Whereas technically, some simple mathematics can be done right at the office where you don't even need to send someone out to do any actual measurement. However, you might be thinking this is pretty tedious. And while yes, I agree with you, it is tedious, there is a way we can shorten it a little bit. And that is the primary skill to learn in this particular screencast. Instead of setting up 4 equations and then solving 4 equations, we instead could approach it this way. We want to solve for w in p equals 2l plus 2w. And even though it says to solve for w, that does not mean that we are going to get an actual number for w, because this equation has 3 variables in it. What it means when it says solve for w, when you don't have specific numbers for p and l, that means to isolate w. So first, we need to make sure to understand the language here. It means to isolate w in the equation. So solve for w in p equals 2l plus 2w means to rewrite the equation in a legal way so that w is isolated. The formula currently has p isolated, the perimeter, but we could rewrite this with the width w isolated. So we need to solve this equation for w by doing the same sort of things that we did with equations with just one variable, but now just with an equation with multiple variables. Because of all the variables in the formula, I'm just going to put a little red box around the w that we want to isolate. So ultimately, you have to identify what's happening to w and then undo that using the inverse operations. So technically, w is first being multiplied by 2, and then you're adding on 2l. You're adding on this thing. So the way to undo adding on this thing is to subtract that thing from both sides. So let's actually just write that in. We've got minus 2l and subtract 2l over here. So we want to subtract 2l from p, but they're not like terms. So we simply just need to write down p minus 2l. And then that equals 2 times w, because 2l minus 2l plus 2w leaves us with just 2w. And then, of course, now to isolate the w here, we need to divide by 2. So if you divide both sides by 2, we get just w over here on the right equals, and on the left, we could technically write this expression, but let's use the distributive property since we have a difference on the top here, and divide the 2 into each of these pieces. So 2 into the p would just be p over 2, minus the 2 into the 2l would give us just l. This formula right here is equivalent to the original formula, but in this version of it, w is isolated, whereas p was isolated in this one. Now, so we technically solved one equation right here. Now, to get the missing widths, we actually don't have an equation to solve. All we need to do is plug in these perimeters and lengths and do just some arithmetic here. So we solved one equation, and now we just need to do arithmetic 4 times. So we've got, for this first one, 1 Gauss Boulevard, we've got 180 divided by 2 minus the length is 50, which gives us 40. For the next one, we've got 170 divided by 2 minus the length is 50, which gives us 35. The next one, we've got 176, the perimeter, divided by 2 minus its length, which is 48, which gives us 40 again. And then the next one, we've got 162 divided by 2 minus the length of 48, which gives us 33. So we get the exact same thing we got here on the previous screen, but on this screen, we simply solved one equation and then just did some arithmetic. Whereas on the previous screen, we had to set up and solve 4 separate equations. This is a little bit more efficient in this way. However, we need to practice with this skill right here. How do you isolate a variable when you've got a bunch of variables in the equation itself, which is known as a literal equation?